Hi, Year 11. So this is our next video that continues on with our compound angles. And what these questions are looking at are exact values of angles, but they're not the ones that are in our triangles. So I'll just go and copy a exact value triangle over for us. So they're the triangles from our HSC formula sheet. And what we're used to doing is finding exact values of 45 degrees, 90, 30, 60, obviously 180, 270 and 360. But what we can now do using our compound angles is find exact values of things like sine 75. Now, in order to do that, we want to think of, well, how can we make 75 degrees out of angles that we already know exact values of? And that would be sine of 45 plus 30 degrees, because 45 and 30 is 75. Now this is basically looking at the rule of sine of A plus B. So we need to go and grab that one off our formula sheet. So if we have a look at our formula sheet, we're given these rules here. Okay, now sine of A plus B, that's the one we want to do. And that is sine A cos B plus cos A sine B. And I've just highlighted that rule there for us. So in order to solve sine of 75, how I've split it up into 45 and the 30 would be our A, the 30 would be our B. So what that would be equal to would be sine of 45 cos of 30 plus cos of 45 sine of 30. And we're going to use our special triangles, which we're used to doing, to work out each of those. So if you want to pause the video and double check that you're getting what I've got here for each of my parts in the compound angle formula, and just neatening that up, we're going to end up with root 3 on 2 root 2 plus 1 on 2 root 2, which is going to be root 3. Oops, sorry, that should be a 2 there. Let's fix that up. Root 3 plus 1 on 2 root 2, in which we could also rationalize that denominator. Okay, let's have a look at our next one. Finding the value of cos 15 degrees. Okay, in order to find the exact value of cos 15 degrees, there's not going to be any values that we can add up to get to 15. We're going to need to do a subtraction. And that would be cos of, think about what we've got, 60 take away 45 would give us 15, and so we can work that one out. Now we need to know our rules for that one as well. Or what you might have chosen was cos of 45 minus 30. Either way will work. I'm going to choose the first one because that's the one that I've got there as first. We need to think of what our rule would be for cos of A minus B. Let's look that one up. There's the rule I snipped from the formula sheet from the last question. This is cos of A plus B. Our HSC formula sheet doesn't give us cos of A minus B, so we need to think about what happens for that one, and we've proved that up above, so we can either write that down or we can rethink right now of what that is. So what we did was we replaced the B by the minus B, okay? So then we'd have that equal to cos of A, cos of minus B, minus sine of A, sine of minus B. We thought about what happened in our Alsatian's two central quadrants, so that became cos of A minus B, which was cos of A, cos of B, because in our fourth quadrant, when we go back to minus B, cos is positive, so this becomes positive. What will then happen is our sine of A will stay the same, and our sine of minus B being down here gives us a negative for the sine of minus B. It becomes minus sine of B, which makes this one a plus, and that one goes to sine of B. If you want to choose to remember that rule, that's fine. I like to work them out because it's one less thing that I need to remember. So if we use my first way, cos of 60 minus 45, I'm going to get cos of 60 cos of 45 plus sine of 60 sine of 45. I'm going to pause the video, pop your values in for there and see if it's the same as mine. Just going to neaten my answers up there, and that will become 1 over 2 root 2 plus root 3 over 2 root 2, which equals 1 plus root 3, or root 3 plus 1 over 2 root 2. Okay, had you chosen to use the cos 45 minus 30 instead of the 60 minus 45, it would work through and give you the same answer. Let's look at the next example. This one's a prove. Prove that tan of 45 plus phi, you can just call it theta, is equal to 1 plus tan theta over 1 minus tan theta. So let's have a look on the formula sheet and see what rule we get given to remember. Okay, so we're given that rule, that tan of A plus B is tan A plus tan B, 1 minus tan A tan B. So I'm going to write that one straight in. Because this is a proof, I'm going to set it out like a proof. So I'm going to start with my left-hand side is equal to tan of 45 plus theta. And that's going to be equal to, I'm going to pop it straight into my rule here because we've got that rule. That's going to be equal to tan of 45 plus tan of theta over 1 minus tan of 45 tan of theta. Okay. Using our special triangles, we can sort the tan 45s out, and tan of 45 is 1, so we get 1 plus tan of theta all over 1 minus 1 times tan of theta, which, if we have a look back to our question up there, which is what we wanted, so that equals our right hand side. So that one was a nice simple one. Let's look at the next one. Okay, so we want to prove that tan x plus tan y equals sine x plus y over cos x cos y. Okay, so I know a lot of you are going to be tempted to cross multiply, but it does say prove, so I want to start with my left hand side and see if I can work down to get this. So let's do that. The left-hand side is tan x plus tan y. Now, we know that tan is sine over cos. So by changing our tans to sine over cos, we've already got some of what our right-hand side needs to be. So let's do that. So tan x becomes sine x on cos x, and tan y becomes sine y on cos y. Okay, so we need to get both of these over the same denominator. So it's just a nice simple algebraic fraction. So we're going to have on the bottom cos x cos y, and on the top we're going to have sine x cos y plus sine y cos x. Our bottom line is where it needs to be. Now, let's go and check what our sine x plus y is. If you go and check back onto your formula sheet, this rule here is this one here. So it's just in the reverse order. So we now have sine x plus y over cos of x, cos of y, which is the right-hand side.